What if instead of describing a broken UI, you could just show it to an AI and it fixes it instantly? No typing, no explaining. You show it, it understands, it fixes it. Or you drop in a Figma design and it gives you back real working code. Not something close, not AI-ish code. Code that actually matches the design. Right now, most people are still doing this the hard way, sending screenshots to Claude, GPT, Cursor, and then writing paragraphs explaining what's wrong. And that's where things break, because every time you translate a UI into words, you lose information. Every time you describe a bug instead of showing it, you're doing work that AI should be doing. Z.ai just released GLM-5V Turbo to remove that step entirely, and the result? On Design 2 code, it scores 94.8. Claude Opus 4.6, 77.3. That's not a small improvement. That's a completely different level of understanding for this kind of task. So what exactly is GLM-5V Turbo, and why does it matter? Before we go deeper, let's clarify what vision coding actually means here. Most AI coding tools are text in, text out. You describe what you want, and the AI writes code from that description. That works. Until what you're trying to describe is visual. Think about a Figma mockup. You don't send the design, you translate it into words. Layout, spacing, structure. And the AI gives you something close but not exact because words lose detail. Spatial relationships, proportions, visual hierarchy. They don't survive that translation cleanly. That translation step, visual to words to code, is where errors get introduced. Vision coding removes that step entirely. The image goes in. The code comes out. That's what GLM-5V Turbo is built for. The V literally stands for vision. It's built on top of GLM-5, a 744 billion parameter model. But instead of adding vision later, this one is designed to handle it natively, and that distinction matters. Every vision language model before this has a version of the same problem. Researchers call it the seesaw effect. You improve the model's visual recognition, spatial accuracy, layout understanding, fine-grained detail, and the code quality degrades. You push the coding ability and the visual understanding slips. It's a constant trade-off. Most labs pick a side and accept the compromise. The reason it happens is architectural. Older vision language models used a two-step pipeline. A vision encoder would convert the image into a text description, and then the language model processed that text. By the time the LLM sees anything visual, the spatial information has already been flattened. Coordinate relationships, layout hierarchy, component depth. All of that gets translated into words, and words are imprecise. GLM-5V Turbo takes a different approach on both counts. For architecture, they make two key decisions. First, native multimodal fusion. Instead of translating images into text, it processes visuals directly, keeping spatial detail intact. This is handled by CogViT Z.ai's vision encoder, designed to preserve layout, spacing, and component relationships. So when the model sees a UI, it understands the structure, not a rough description. That's why the code matches the design instead of approximating it. Second, multi-token prediction. Most models generate one token at a time. This one generates multiple at once, making it faster and more stable, especially for long code or agent workflows. But architecture alone doesn't solve the real problem. The seesaw still exists. GLM-5V Turbo tackles it during training. Instead of separating vision and coding, it trains both together, using joint reinforcement learning across 30-plus tasks, across reasoning, visual grounding, video understanding, and tool use. So the model learns both skills at the same time, and the result is clear. 94.8 on design to code versus 77.3 for Claude Opus 4.6. But more importantly, it keeps strong performance in pure text coding too, so adding vision didn't break coding. For the first time, the seesaw isn't swinging anymore. Most models stop at perceive, they describe what they see. GLM-5V Turbo goes further. It closes the loop. Perceive, plan, execute. Here's what that means in practice. You give it a design, it builds the front end. You send a broken UI, it finds the issue and fixes it with code. No explaining, no translating. And inside agent workflows, it doesn't just respond, it can take actions across steps. That's why it performs well on real-world benchmarks like Web Voyager and Android World. It's not just seeing, it's acting. Now it's time to compare versus Claude Opus 4.6. Claude can take images, but it's still a text-first model with vision added on top. GLM-5V Turbo is built differently. Vision is native, and the gap shows. On Design to Code 94.8 versus 77.3. On agentic browsing, GLM5 hits 62.0, Claude Opus 4.5 sits at 37.0. For vision first coding tasks, this isn't close. Then there's cost. Claude, $5 input, $25 output per million tokens. GLM5V Turbo, $1.20 input, $4 output. That's roughly 4 to 6 times cheaper, especially important if you're processing lots of screenshots or designs in a loop. But Claude still wins in some areas. General reasoning, ambiguous instructions, pure text workflows. If your workflow starts with text, GLM5 or 5.1 actually makes more sense than 5V Turbo. This model is specialized. Versus GPT 5.4. GPT 5.4's strength is computer use, around 75% on OS World. That's broad system control. GLM-5V Turbo is narrower but deeper. It's optimized for UI understanding and spatial accuracy, not general navigation. Different tools, different jobs, versus Kimi K 2.5. Kimi is closer in philosophy, native multimodal, but GLM-5V Turbo has a key advantage. It's trained directly around OpenClaw workflows, so if you're building in that ecosystem, it has the edge. Now, quick reality check. Some of Z.AI's benchmarks are internal, and any self-reported numbers should be taken with skepticism, but not all of them. The Design to Code Score, Android World, Web Voyager, those are independent, and even their past claims like GLM5's SWE bench performance were externally verified. So the exact numbers might shift, but the direction is consistent. And one more thing, the real wildcard here isn't even in this comparison. DeepSeek's V4 is coming. If they bring the same pricing, around 28 cents per million tokens, into multimodal with competitive quality, this entire space resets overnight. So how do you actually use this? Access is simple. It's available on OpenRouter. Just select GLM5V Turbo. Pricing is $1.20 input, $4 output per million tokens with a 200,000 context window. It's OpenAI compatible, so integration is just swapping the model name and base URL. Z.AI also bundles it into their GLM coding plan. So if you're already using that, you get vision support without extra setup. Use it when the input is visual. If you're building agents that interact with UIs, especially in OpenClaw, this is the right tool. It's trained for that environment. If you're working with screenshots, UI bugs, or Figma designs, route those tasks here. Let it handle perception instead of forcing text models to guess. If your workflow is text only, don't use it. GLM5 or 5.1 will be cheaper and better. This isn't a general upgrade. It's a specialized tool for visual workflows. So here's the bottom line. If your workflow is visual, designs, screenshots, UI bugs, this changes how you work. You stop describing, you start showing. And the model handles the rest. That's the real shift here. I'd really like to know what you think about it. Drop a comment, and if you want more breakdowns like this, hit subscribe.